Assalamualaikum and hello everyone. Welcome to a new video of 4.4 intermolecular forces. In this video, we're going to describe intermolecular forces, which is hydrogen bonding, and then we're going to relate the effects of hydrogen bonding on the boiling point, solubility and density of water compared to ice. And then actually we're going to explain juga factors that influence the strength of hydrogen bond. So on your notes, it will be on page 39. So what is actually a hydrogen bond? Hydrogen bond ni is actually a type of permanent dipole juga, dipole force. Tapi hydrogen bond dia special lagi. It's actually attraction between the positively charged H atom and the negatively charged electronegative atom, FON. Because remember, contohnya kalau misalnya buat yang senof tu kan, senof, this is actually increasing electronegativity. So, our nitrogen, oxygen and fluorine ni is highly electronegative. Senang nak ingat dia phone lah. Tapi sebenarnya, kalau order of increasing electronegativity, it will be the other way round. Okay, tapi senang nak ingat, hydrogen bond ni is actually between hydrogen and the negatively charged and the highly electronegative atom, be it fluorine, oxygen or nitrogen. But it must be, sebenarnya kalau hydrogen bond, the fluorine ni ataupun our electronegative atom ni must be bonded to our hydrogen. So example dia FH, OH and H. So contohnya, okay, senangnya kita nak buat sini lah yang paling famous kita tahu, okay, hydrogen fluorine, okay, HF kan. This is actually memang kita punya hydrogen bond. Tapi kalau contohnya I have CH3F, kita belajar previous video kan, CH3F. Hydrogen. So, kat sini kita nampak hydrogen dengan fluorine. But does the fluorine bonded to hydrogen ke tidak? Sebenarnya fluorine ni is bonded to carbon. It's not bonded to hydrogen. So, this is actually our hydrogen bond. This is not our hydrogen bond. So, make sure you know that the fluorine, oxygen dengan nitrogen yang phone tu must be bonded to hydrogen. Macam ni. Kalau it's not bonded to hydrogen, it is not a hydrogen. There is no hydrogen bonding lah between the molecule itself. Then yang kali ni, senangnya partial positive ni it must be on our hydrogen. Okay, so that is actually for the introduction of hydrogen bond. Sekejap sahaja. Okay, next is actually kita nak tengok is between hydrogen fluoride H2O dengan our ammonia. Okay, so dalam kes ni sebenarnya for each hydrogen, okay, sebenarnya kita nak macam mana? Okay ni, we have HF 1, 2, 3, 4. We have 4 hydrogen fluoride kan? Okay, actually, apa ni? For each of HF ni, so contohnya sudah sini lah. Contohnya, for each of my hydrogen fluoride ni, actually I can form 2 hydrogen bond. Okay, kenapa can form 2? Sebab sini ada first hydrogen bond. This is the first hydrogen bond. This is the second hydrogen bond. So, for each of our HF, it actually can form 2 hydrogen bonding. So, that is for case of HF. Okay, kalau in terms of H2O. So, contohnya dekat sini, I'm just gonna write down. So, this is my center. Kita guna ni lah. This is my H2O. Okay, kat sini berapa hydrogen bond dia boleh form? Dia boleh form 1, 2, 3, 4. Okay, so even though structure dekat sini hanya tunjuk ni kan, tapi sebenarnya this water pun sebenarnya boleh form lagi dengan another water. Ni 1, 2, ni ada lagi. Sebenarnya boleh lagi lah, tapi ini just for you, for me to show so that it is clear to you that for each of our water molecule, it actually can form 4 hydrogen bond. So H2O ni can form 4 hydrogen bonding. Okay. Next is actually between our ammonia and H3. So remember, N2 is bonded to our hydrogen kan? Okay, so dalam case ni, kita colorkan ini. Okay, so for each of my ammonia, it actually can have 1, 2 hydrogen. So NH3 can form 2 hydrogen bonding. Okay. Why? Because it's actually sebenarnya nak form hydrogen bond ni, satu is the hydrogen tu must be bonded is attracted to the lone pair on our electronegative atom. Okay. So, ini sebenarnya the case of HF, H2O dengan NH3. It has different number of hydrogen bonding lah. Where water yang can form maximum number of hydrogen bonding boleh 4. Okay. So, that is actually for the case of HF, H2O dengan NH3. Okay, so sekarang ni kita nak tengok the effects of hydrogen bonding on properties. So, first one is boiling point. Okay, so kalau boiling point sebelum ni kita belajar apa? SSP. So, this first ni size, shape, polarity. Tapi sekarang ni we're gonna look for the case of this is actually in group. So now let's look here for boiling point higher than usual. Okay, so when we know kan SSP, size. When the size ataupun molecular weight, so what happens is that the strength of the van der Waal pun akan increase. Okay. Why? Because actually kalau contohnya between kalau non-polar molecule kan, what will happen is that dispersion force when the molecular weight to increase ataupun number of the electron increase, we have a stronger attraction. Contohnya kita tengok dekat sini lah, kita compare ni between helium yang kecil ni dengan krypton yang we have a bigger size. So bila the bigger size, it will have a stronger attraction ataupun a stronger intermolecular force. Okay. So what happens is that more energy is needed lah kalau kita nak break the bond between the molecules. We need more energy to overcome the force. So that's why we will have the boiling point increase. Okay, so this is actually applicable macam biasalah yang ni, group 14 ni. Carbon, silicon, germanium dengan SN. Tak ingat lah. Kita punya, this is the molecule. Sebab this is actually down the group 14. Okay, tapi dekat sini, bila kita tengok untuk group 15, 16, 17, it is different. So, kalau kita tengok, okay, kalau dalam case, senang kita tengok yang group 15 ni lah. Okay, yang the purple one ni. Okay, NH3 ni yang paling tinggi. Okay, NH3 ni tinggi. Lepas tu pH3 is lower. But then, kita punya arsenic ni dah tinggi sikit. It's the same. It's quite similar. Dia tinggi sikit daripada kita punya nitrogen. Sebab shape dia ataupun dia punya size is bigger. Tapi kalau kita compare between our NH3 dengan pH3 ni, okay, NH3 ni is higher sebab dia ada hydrogen bond. The same goes for HF ni. Tengok HF, HCl. Kalau kita tengok dekat sini, HF ni dia lagi tinggi lagi pada HCl, lagi tinggi pada HBr dan lagi tinggi pada HI. Sebenarnya hydrogen fluoride ni has a higher boiling point. Dia yang paling tinggi sekali between group 17 punya molecule ni. Okay. And then kita tengok yang group 16 ni pula. Okay. Tapi kenapa dekat sini H2O ni pula, group 16 pun sama juga. H2O will have the higher boiling point in group 16. Which is H2S ni ke H2T ini, kita tengok when the size increase, so what will happen is that the boiling point pun akan increase lah because our force of our intermolecular force is stronger. Tapi dalam case ni, H2O ni is the highest. Okay, why? This is actually because these three molecule have hydrogen bonding. So sebab itulah dia ada exception sikit. Okay, so that is explaining why the boiling point is higher than usual. Okay, but right now, kita tengok ini is between the molecule. So now we're gonna look between these three molecule itself. Kita akan comparekan why H2O has the highest boiling point and our NH3 has the lowest boiling point. So the H2O is the highest while NH3 is the weakest one. So the boiling point increases in such order. So kita tengoklah daripada sini. Yang ini higher boiling point. So kat sini the weakest is NH3 followed by HF and the strongest is H2O. So I'm just gonna write it down here. So dia jadi NH3, HF dengan H2O. So sebenarnya the strength of hydrogen bonding is proportional to the number of bond. Okay. Okay, sebenarnya bila kita comparekan between H2O, HF dengan NH3, H2O has the highest number of hydrogen bonding, ada 4. So that's why lah it has the highest bonding point. Okay. So even though fluorine is more electronegative, H2O has higher boiling point. So sebenarnya H2O ni can form more hydrogen bonding than HF. Where there are 4 hydrogen bonding per H2O molecule compared to only 2 per HF molecule. So contohnya kita tengok H2O ni ada 4 hydrogen bonding tapi HF dia ada 2. So that's why lah H2O ni has higher boiling point. Tapi sekarang ni bila HF dengan NH3 dia masing-masing ada 2 hydrogen bonding. So which factor that we're going to look at is actually based upon the electronegativity. So between our fluorine dengan our nitrogen, fluorine is more electronegative. So that's why HF is higher than boiling point, has higher boiling point than NH3 because F is more electronegative than N. Okay. So, for the case of hydrogen bond, what we're going to look at is actually first the number of bond. Next, kita akan tengok which one has the higher electronegativity. That will have the stronger, a stronger hydrogen bond. Factors je, it will be which is called electronegativity ni order dia F is stronger than oxygen. Oxygen is stronger than nitrogen. Font. Walaupun dia font, tapi remember dia punya arrangement dia CNOF. Higher EN. Okay, so that is actually for our boiling point. Boiling point yang panjang sikit. Okay, next is actually solubility. Okay, so for solubility, compound that can form hydrogen bonding with water are soluble. So contohnya amine ni. So amine ni is actually on our nitrogen ni is bonded to hydrogen. So for our nitrogen in amine ni is bonded to hydrogen kan, and the lone pair here can form hydrogen bond with our water molecule. Okay, next alcohol. So alcohol kita, our OH on our alcohol can form hydrogen bond with our water. And for the case of carboxylic acid is this one. This is our carboxylic acid. Ni kali je lah. This is alcohol. And this is our amine. Okay. For the case of carboxylic acid, the oxygen, the double bonded oxygen ni can form hydrogen bond with our water. The same goes for the case of hydrogen which is bonded to the oxygen here can also form hydrogen bond with water. So when the organic molecule can form hydrogen bond with water, hence it is soluble. Dia soluble tu maknanya dissolve in water lah. Macam mana kamu makan Panadol soluble tu kan. Okay, and last but not least is actually we're going to look at the case of density of water compared to ice. Okay, so when cooled to a solid, the water molecule arrange themselves to form tetrahedral arrangement to maximize the amount of hydrogen bonding between them. Okay, so yang inilah sebab kalau kita tahu water itself, water ni H, okay, oxygen H, and then we have our ni kan. So this is a band shape. This is actually our molecular geometry. Okay, but we know kalau dia punya electron pair geometry, dia sebenarnya adalah tetrahedral kan. So contohnya sini ada 1, 2. But then the bonding pair ni is being replaced with lone pair kan. Originally kalau dia punya electron pair geometry is actually tetrahedral. So that's why the water molecule ni akan arrange themselves to form tetrahedral arrangement. So that's why dia boleh form tetrahedral arrangement. So when it form tetrahedral arrangement, this leaves a relatively large amount of space between them. So kita tengok sini kan ada space yang besar ni. We have our hexagon shape. So this arrangement of molecule has greater volume than liquid water. Thus water expands when frozen. Okay, and then the open structure of the ice account for the fact that it is less dense than water. So that's why lah when you drink ice water, the ice will be floated. Sebab it is it is less dense than water. So bila kita minum air tu, memang ais tu dah akan floated ke atas lah. Memang tak pernah lah ais tu di bawah kan. Okay, so that is actually why ice is floated above the water itself. Dense than water because it is less dense than water due to the hydrogen bonding dia lah. And yeah, they form tetrahedral arrangement. So that's the last of our hydrogen bonding.